Hello, everyone. I believe we can start right now. And I'm Shabam, Senior Product Marketing Manager at ZTR, and your host for today. Welcome, everyone, to our webinar on reducing locomotive idling, fuel consumption, and emissions through AESS systems. This is with a focus on SmartStart AESS. And this session will delve into how AESS systems are positively impacting the rail industry by addressing critical challenges such as excessive idling, fuel inefficiency, and emissions. So as we navigate through the intricacies of AESS technology, we'll touch upon benefits, considerations, adoption strategy, discuss the financial gains reported by rail operators, and unveil the measurable impact on emissions reduction. So this webinar aims to provide a comprehensive understanding of how AESS, particularly SmartStart or AESS, offers a viable solution to not only meet regulatory requirements, but also drive substantial fuel savings and contribute to a greener future for our rail industry. I'd like to welcome our two distinguished panelists, Steve Cable and Amarjeet Sura. Steve Cable is a key account manager with ZTR. He is the go-to expert for client correspondences and strategic planning for some of ZTR's largest accounts. So with an impressive career spanning almost 20 years at ZTR, including 15 years as the Senior Technical Service Representative, Steve has provided top-tier technical support for all ZTR's legacy and current products. Amarjeet Sura is our Senior Product Manager. Amarjeet's background is electrical engineering, and he has spent most of the last 27 years in various engineering roles in the rail industry. Having been with ZTR for 24 years, Amarjeet now oversees the introduction and life cycle of ZTR's control and monitoring solutions for the rail industry. Amarjeet also has held various positions in Locomotive Maintenance Officers Association Electrical Committee and currently is a regional executive over there. So I'd say don't miss this opportunity to gain insights from these industry veterans on how AESS systems remarkably benefit rail operations. Please feel free to drop in any questions you have in the questions pane, message me, or ask right away. I'll pass it on to Steve to take on the session. Steve.
Thanks, Shabam. Appreciate the kind words. I didn't even recognize you were talking about me at first. It was so nice. So appreciate that. And Am, always a pleasure to work alongside you and get a glimpse of some of the magic that you've done over the years. So appreciate you guys being here. Everyone else?
Looking forward to this, Steve.
Yeah. Everyone else, I guess, good morning, good afternoon, or good evening, depending on where you're at. I'll throw some slides up here and speak to it and save you guys all from having to look at me until question and answer. So I'll turn off my camera and we'll get to it. As Shabam said, if you've got any imminent questions, whatever those might be, feel free to speak up. Otherwise, send your written questions in the chat through to Shabam and we'll try to deal with them all after the presentation. So without further ado, Shabam, if you'll pass me the screen, I will.
Oops, yep, I'll do that right away.
No, you're good. Excellent. Okay, you guys can see what I'm seeing now?
Yep, I can.
Perfect. Okay, I will again save you my visual image for the next 20 or 30 minutes then. Okay, so I know people are probably joining in from multiple different locations. So again, thanks for doing that. This is a topic we're all pretty passionate about with our years with ZTR and in the industry. It's something that's we've spent a lot of time thinking about, and we're very grateful to be able to share our thoughts and product with you. So thanks again. So we're here to talk about AESS. What is AESS? The acronym stands for Automatic Engine Stop Start. So we're going to be using that over and over again. If you're familiar with it, great. If you're not, hang on for the ride. So in today's railway landscape, innovative technologies are a crucial item for efficiency, emissions reductions, and compliance. The rail industry plays such a crucial role in the transportation industry with a strong emphasis on efficiency, cost reduction, and more recently, environmental sustainability, with goals spanning out into roughly 2050. So this really has a huge impact on what we're going to talk about today. So with this focus on improving operational performance, reducing carbon footprint, the rail industry is continually looking for technical solutions to improve locomotive efficiency, reduce their operating expenditures, and also increase environmental sustainability. So the webinar we're presenting today, we're aiming to explore the transformative powers of automatic engine start-stop systems as they relate to diesel-electric locomotives in our case, and more specifically the SmartStart AESS and how it helps to achieve fuel savings, emissions reductions, and operational advancements. So before we dive into the webinar in any detail, we had a quick question for you. We promise after this we'll do the heavy lifting, but if you can help us out, Shabam's going to put up a poll on the screen, and we're looking on a scale of 1 to 5, 1 being not important, 5 being extremely important to you or your organization. How would you rate the importance of reducing fuel consumption in your rail operations? So I'll give you guys a few minutes to reread the question and put in your opinion there, and then we'll continue on with our chat. Okay, Shabam, how are we looking on the poll?
So this is the result. Like, I believe it's very important and extremely important for most of us. So that's good to know.
Good, okay. So, and some of this is for us to take away afterwards and to engage with people individually. So appreciate anyone who did participate in the poll, and hopefully if you were on the lower end of the scale, then after this presentation, we'll have bumped you up a couple points. I think at this point, we will go on again. All right. So with any initiative changing the way things work in rail, there are challenges. So rail transportation is no exception here. As a vital pillar of global commerce and connectivity, and has long been dependent on traditional engine management methods. However, these methods, which largely rely on human intervention, often fall short of achieving optimal results in terms of emissions reduction and fuel efficiency. The inherent limitations of manual shutdown and startup procedures introduce errors, inconsistencies, leading to suboptimal efficiency gains. Another significant challenge is inefficient emission reductions. So with the global push for environmentally responsible practices, railways are under increasing pressure to minimize their carbon footprint. However, manual shutdown and startup procedures do not offer the precision and consistency required to achieve optimal emissions reductions. Inconsistencies in timing and execution often result in unnecessary idling periods, leading to excessive fuel consumption and then therefore emission generation. These inefficiencies not only hamper railways' efforts to comply with stringent emission regulations, but also hinder their ability to demonstrate proactive environmental stewardship. Resistance to change is a challenge that shouldn't be discounted. Railroad personnel are accustomed to established methods, may be hesitant to embrace change, disruptions to their routines and operations. Like any of us, change is hard. Convincing stakeholders of the benefits and the viability of the advanced technologies can be challenging, slowing down the adoption of innovations that could significantly improve efficiency and sustainability. Overcoming this resistance and facilitating a smooth transition to more advanced engine management systems is a crucial challenge that must be addressed. An automatic stop-start system, AESS, operates by intelligently managing the engine shutdown and startup processes on the locomotives. So equipped with sensors that monitor crucial parameters such as battery charge, engine coolant temperature, air pressures in the braking system, operational status, the AESS system makes real-time decisions based on predefined criteria. So when the locomotive is idling and certain conditions are met, such as appropriate temperatures, sufficient battery charge, and no impending use, as in the operator's not trying to use the equipment for day-to-day freight hauling, switching initiatives, the AESS then initiates an automatic shutdown. So conversely, when the locomotive is needed for operation or certain parameters meet a critical threshold requiring attention, the AESS system seamlessly restarts the engine. This automated cycle not only reduces necessary idling and associated fuel consumption, but also ensures optimal engine performance and compliance with emission regulations. We've got lots of different configuration options available for different locomotives, which we'll get into more later, but we know that all locomotives are not necessarily created equally. All switching yards or road operations have different criteria required to meet their success metrics. And AESS, the SmartStart in particular by ZTR, has touched on a lot of these different nuances over the years and made configuration options available to meet these various needs. In addition to core functionality of an automatic engine start-stop system, the integration of data connectivity brings a new dimension to the efficiency and management of locomotives. AESS with data connectivity leverages real-time data analysis to provide actionable insights into engine performance, fuel consumption, and emissions. By harnessing the power of data, it not only automates engine processes, but also provides a wealth of insights into fuel efficiency, emission reductions, and overall operational performance. We'll dwell into the benefits of this data connectivity later in the presentation. Subsequent slides delve into the specifics of SmartStart AESS, highlighting its role as a pioneering solution in the realm of AESS technology. This includes a comprehensive analysis of its features, the benefits of it, and its advanced capabilities with data connectivity. While some of features and benefits mentioned for SmartStart AESS will be available on other AESS systems, some features, benefits, and capabilities are available only with the ZTR SmartStart AESS. So SmartStart, ZTR's AESS system. It's an industry-leading automatic engine start-stop system. It's excelled in reducing and managing locomotive idling to delivery exceptional, and allowed delivery of exceptional fuel savings over 30 plus years of global history. So many major railroads across the globe trust SmartStart AESS, and it's been installed on over 10,000 locomotives globally to date. So there's a lot of experience there. We've learned along the way, we've listened along the way. This is a tried and true proven product. SmartStart AESS enables shift from manual engine management to a fully automated solution. By eliminating the need for operator intervention, SmartStart ensures consistent and optimal engine shutdown and startup processes. This automated approach eradicates human error and inconsistencies, resulting in precise timing that maximizes fuel savings and therefore emissions reductions. SmartStart uses advanced algorithms and real-time monitoring capabilities to achieve optimal emissions reduction. By analyzing various parameters such as engine temperature, battery charge, and safety systems, SmartStart ensures that engines are restarted before critical operating thresholds are breached. This proactive approach prevents situations where engine parameters dip too low of a level. It allows it to preserve battery life for when it's needed and minimizing the risk of engine damage due to freezing in cold temperatures. SmartStart's versatility extends across the entire spectrum of locomotives. Regardless of the manufacturer, the model, the age, or usage case, SmartStart can be seamlessly integrated into a wide range of locomotives. This adaptability eliminates the need for extensive modifications, making it an ideal retrofit solution. So we can essentially apply SmartStart to any model of diesel electric locomotive out there that we've seen in the last 30 years. So it's a very versatile product with minimal optimizations to cover the different scenarios that are out there. The heart of the SmartStart's value proposition lies in its ability to deliver significant fuel savings. So by reducing unnecessary idling time, SmartStart minimizes fuel consumption and associated costs. Studies indicate potential savings of 5,000 to 8,000 gallons of fuel per locomotive annually, resulting in a substantial financial benefit for rail operators. For our participants who are more comfortable with the metric system, we're talking 19,000 liters to 30,000 liters of fuel savings annually per locomotive. By curbing unnecessary idling and fine-tuning engine restarts, SmartStart contributes to lowering the railways industry's carbon footprint. As regulations tighten in different jurisdictions and regions, and environmental concerns intensify, SmartStart offers a concrete and actionable approach to meeting emission reduction targets. To put in a different context, if we assume 8,000 gallons of fuel per locomotive saved annually, this works out to 20 automobiles taken off the road, 88 acres of trees saved annually, or 80 tons of CO2 emissions reduced. So these are significant gains that we're seeing just from reducing the amount of idle time that an engine is allowed to do per day or per year, I suppose. With accurate and up-to-date data at their disposal, rail operators can easily demonstrate their adherence to regulatory requirements and corporate sustainability goals. Beyond fuel savings and emission reductions, SmartStart offers operational improvements as well. So features such as load shedding for your headlights and cab lighting, battery saver, which allows the locomotive to be shut down manually and not necessarily rely on an operator to pull the knife switch when they're done, and automated notifications using our remote connectivity through our Saver remote monitoring option. They all contribute to smoother operations and improved locomotive reliability. SmartStart's expandable technology paves the way for ongoing enhancements, from extended fuel-saving capabilities to compatibility with additional onboard systems. SmartStart's flexibility ensures that its benefits can evolve alongside the changing industry demands. So you don't have a product line out for 30 years without being able to adapt and evolve alongside of the rest of the rail industry. And SmartStart is no exception here. So remember we spoke about automatic engine start stops with data connectivity. So we're gonna come back to that now. So Saver is an add-on option to the SmartStart AESS. It's an advanced feature of the SmartStart AESS system that offers a comprehensive set of benefits beyond the core automatic engine start-stop functionality. So Saver, it stands for SmartStart Advanced Vehicle Enhancement and Reporting, provides additional advantages for fleet management, fuel savings, and operational efficiency. Let's talk a little bit more about Saver and remote connectivity. So one of the key features and applications of Saver is GPS location and geofencing. SmartStart Saver includes GPS technology that allows for real-time tracking and monitoring of locomotives equipped with the SmartStart system. Geofencing capabilities enable the definition of virtual boundaries or zones, and notifications are triggered when a locomotive enters or exits these predefined areas. SmartStart Saver provides comprehensive fleet reports that offer insights into the performance of Saver-equipped locomotives. These reports can include data on fuel consumption, emission reductions, engine start-stop patterns, and other operational metrics, all available online in near live time. By analyzing the data collected by Saver, railroads can uncover patterns, trends, and areas for improvement in fuel efficiency, emission reduction, and locomotive utilization. Some studies have shown that without visibility on locomotive issues preventing maximum returns, major railroads could be losing millions of dollars annually across their fleet in unrealized savings. On top of the fuel saving related data points, there's also inferred data that we can get monitoring different data points that we are typically using for fuel savings data. So like most things, the harder you look at the data, the more you can find other cases in which patterns start to appear, such as, is my compressor pumping air better, less, or the same as it was 2 months ago? We can actually trend certain data points and look for changes in their outcomes or changes in their productivity over time, leading to potential maintenance insights that may not have been there otherwise. So with any kind of big data and data analysis, the actual possibilities surrounding what we can do with that data expand on a daily basis. So while the core benefits of SmartStart AESS are evident in its fuel savings, emissions reductions, and operational enhancements, there exists a set of supplemental and intangible advantages that further solidify its value proposition. So these benefits extend beyond the quantitative metrics, enriching the overall impact of SmartStart for you. One important benefit is reducing the engine wear. By minimizing unnecessary idling, AESS helps to extend the lifespan of critical engine components. This reduction in wear and tear can lead to longer engine life and lower maintenance costs over the locomotive's operational lifetime. Also, by visibly implementing technologies like SmartStart that actively contribute to emissions reductions and environmental responsibility, rail operators can enhance their corporate image. This positive reputation resonates with shippers, investors, and communities, fostering goodwill and potentially attracting new opportunities and partnerships. One of the ancillary advantages of SmartStart lies in its contribution to reducing noise pollution, especially in populated urban areas. SmartStart's automated process ensures that the engines are restarted with precision, minimizing unnecessary idling and abrupt engine noises. Talking about regulatory readiness and adaptability, the railway industry operates within a regulatory landscape that continually evolves to address environmental concerns and technological advancements. By adopting SmartStart AESS, rail operators position themselves as proactive participants in regulatory compliance. SmartStart's ability to monitor, report, and optimize emissions aligns with existing and future emission standards. Another, often not considered benefit is the workforce engagement. SmartStart allows railway personnel to focus on higher value tasks that require human expertise such as maintenance, troubleshooting, safety, and train handling. The transition from routine tasks to more meaningful responsibilities can boost employee job satisfaction and a sense of professional growth. As promising as SmartStart AESS may be in revolutionizing the railway industry, it is essential to acknowledge and address a few items to ensure maximum returns and benefits. The adoption of SmartStart AESS requires an initial investment for rail operators. The installation of sensors, communication infrastructure, and control systems across the locomotive fleet demands capital expenditure. Considering the high returns for SmartStart, these initial investments are legible. However, given all projects must be budgeted and staffed for awareness is important. Another important factor to consider is the workforce training. the transition to SmartStart AESS necessitates a shift in workforce roles and responsibilities. However, rail personnel who were previously involved in manual shutdown and startup procedures can now focus and perform other important urgent tasks. So how do you go about adopting SmartStart AES or any AESS? Well, here's a broad suggested path based on our experience over time with many railroads, many locomotives in many regions. However, this would vary in each organization according to your established practices and SOPs. The first step to adopt an AESS would be a preliminary assessment. So conduct a thorough assessment of your locomotive fleet to identify suitable candidates for AESS implementation. Consider factors such as usage patterns, fuel consumption, emissions, and maintenance requirements for your fleet. We can help with this. The second step would be setting clear objectives for the adoption of the AESS system. These could include reducing fuel consumption, lowering emissions, enhancing operational efficiency, and achieving cost savings. This can be followed by stakeholder engagement that includes identifying key stakeholders who will be affected by the adoption, including locomotive operators, maintenance teams, fleet managers, and executives, communicating the benefits of AESS system and addressing any concerns that each group may have. So when everyone's on board, you work with ZTR team to customize the AESS system to match the specific requirement of your locomotives and operations and ensure seamless integration with existing locomotive control system. So we work with you with our knowledge and experience to build a plan that works based on your business case and operating procedures. The integration of AESS is followed by workforce training. Some of the strengths of SmartStart include its largely transparent operation and low maintenance. Rollout follows the workforce training. We suggest you roll out the SmartStart AESS system gradually across the fleet, starting with locomotives that offer the highest potential for fuel savings and emissions reductions. And again, ZTR can help determine what these are or work with you to determine this. The next step in adoption of an AESS system would be performance monitoring and optimization. You should implement a robust monitoring system to track the performance of the AESS system in terms of fuel savings, emissions reductions, and other key metrics that you choose, and continuously analyze data to identify opportunities for optimization. Setting up a feedback loop and continuous improvement workflow should be the next step. So establish a feedback loop with locomotive operators and maintenance teams to gather insights and suggestions for improvement and collaborate with ZTR to address any issues and implement enhancements that may be available. Finally, when you have successfully implemented and are saving fuel, reducing emissions, it's the time to communicate the progress and achievements of the AESS adoption to stakeholders and regulators. So at this time, we've got another short quiz that if you can all take a second to participate in, we would appreciate it. Shabam's gonna put it up on the screen here for you momentarily. But what we're looking at now is, so the benefits of SmartStart AESS saves up to 8,000 gallons or 30,000 liters of fuel annually per locomotive, has a series of other benefits as well, like reduced engine wear, better workforce engagement, as we've discussed, and more. So given that SmartStart would have an active life of approximately 20 years, what, according to you, would be a good break-even period for SmartStart investment? So we're looking at 4 to 5 years, 3 to 4 years, 2 to 3 years, 1 to 2 years, or less than 1 year. So I'll give you a couple more seconds to make your selection. Okay, and assuming that you all had a chance to make a selection on our poll.
Steve, the poll is still going on. I believe a couple of people just voted. So
Okay.
I'll close this. I guess we are done with the poll, and it's interesting. So 44% people believe 2 to 3 years would be a good break-even period for smart start investment, and 39% say 1 to 2 years. Hmm. That's good to know. And I'll let Steve continue with how do we go about the break-even period and return on investment for a smart start.
All right, thanks, Shabam, and thanks everyone for participating there. So it sounds like 1 to 2 years and 2 to 3 years were the majority of people's opinions based on their knowledge and their specific circumstances at their railroad. So, and that's pretty close. We actually see a lot that are less than 1 year, but it is completely dependent on the operations that your railroad has and some of the use cases. But we're definitely on the closer to less than a year, 1 to 2 years, than we are anywhere near 3 or 4 or 5 years. So the return on investment is quite quick, and then it doesn't stop there. Obviously, every year after that, you're still getting those savings that you can then reinvest into continuous improvements. So this is just a quick little use case or a case study that we've done. So this is some data that isn't from a specific railroad, but it's just based on our curating a bunch of data we've seen over 30 or so years with a kind of an average situation. So if we assume 200 locomotives need to be fitted with an AESS, and then we prioritize the medium and high in-service rates, so higher in-service rates of the locomotive utilization typically seems to trend with the higher return. More use case, more likely that it can shut down at times when it wasn't before. So it kind of makes sense. So if we blend the high use and the medium use cases, we end up with an average savings per year per locomotive of roughly 33,000 in this example's case. So we have the best performers that have the highest savings around $42,000 a year per locomotive, and then the medium case ones around 24. So that's where the 33,000 per year comes back. So using the assumption of the average of 33,000 per year in savings per locomotive, we've projected a 36-month rollout. So it would be based on fleet availability and the supply chain needs, but this would assume roughly 5.5 installations per month. So at that rate, as you can see on our graph, so we get payback achieved in 18 months. So I know we talked about having an ROI of usually less than a year. So that's still happening. What we're talking about with payback on this graph is that's the point at which the previously installed systems have not only paid for themselves individually, but now their savings are actually going towards the purchasing of new SmartStarts. So we're actually hitting a point where the ones that are paid off are now paying for the implementation across the rest of the fleet. So that happens at roughly a year and a half into this particular case study that we're looking at here. So that's the point at which the savings start to actually outweigh the costs required for implementation. And that continues on throughout the rest of this 42-month study. So at the end of the 42 months, we've actually had everything installed before then at roughly, what are we saying, 36 months, at which point we're just making savings on every locomotive in the fleet. And after 42 months, we've got $8 million in savings that's accumulated. So clearly, and we're just talking 200 locomotives in the course of 3 or 4 years. So obviously these are pretty large numbers. So the dollars are hard to deny, and then if you convert that into gallons or liters of fuel saved, it's pretty easy to display what that means from a fuel consumption or an emission saving standpoint. So some powerful stuff here, again, based on very real data that we've accumulated over the years. So, hope that you find that interesting and fascinating. So investing in SmartStart AESS, it's not just a commitment to environmental sustainability, but a strategic move for significant financial gains with a moderate upfront cost ranging between 10,000 to 15,000 per unit. So that's the cost of the hardware, the harnesses, peripheral sensors, main control panel of the unit. So that's a per locomotive cost. The system offers that rapid return on investment that we've talked about, our ROI. So consider this: SmartStart's proven ability to save 5,000 to 8,000 gallons of fuel per locomotive annually translates into a substantial cost savings with the price of fuel that it's at these days, so roughly in the range of $3.50 to $4 per gallon. So with an average fuel cost at $4 per gallon, a rail operator can recoup the initial investment in SmartStart within the first year of implementation. Several major rail operators around the world have already embraced SmartStart AESS and reaped its benefits. The path to success with SmartStart, it enabled through EPA compliance, so SmartStart meets the stringent locomotive emissions requirements set forth by the Environmental Protection Agency. Most of the regulators across the world have established similar emissions requirements, so not just in North America, but worldwide. So by aligning, and the ones that haven't are working towards that. So by aligning with these regulations, SmartStart offers a reliable path to compliance, shielding rail operators from potential penalties and ensuring a seamless transition to environmentally conscious practices. Rail operators have reported annual savings exceeding 28,000 per locomotive through the implementation of SmartStart. So we showed on average 33,000 in our case study a few slides back, but 28,000 is even lower than that, but still obviously gets you well past a 1 year or under a 1 year return on investment per unit. So with a payback period in as little as 6 months, the financial benefits of reduced fuel consumption and optimized engine management become evident within a remarkably short time frame. So this isn't something you've got to invest in for decades. It pays it back, sometimes within the first half year, 6 months, 1 year, maybe 2 years if you're a low utilized unit. But either way, even the worst case scenarios have phenomenal ROI cases. SmartStart's connectivity capabilities extend beyond fuel and emissions reductions. So the system facilitates remote reporting of key performance metrics, enabling all rail operators to monitor their fleet's efficiency and make informed decisions based on real-time data. So this remote access enhances operational control. It empowers rail operators with the insights needed to drive continuous improvement. So you don't need to rely on somebody going out, getting on a unit, downloading it, bringing that in, uploading it to a system. With the advent of IoT and the Saver remote monitoring add-on, this can all happen seamlessly in the background on a daily basis. So as the global transportation sector continues to grapple with the need to reduce greenhouse gas emissions and enhance energy efficiency, SmartStart AESS emerges as a viable solution for the railway industry to contribute to these overarching goals. The potential for substantial fuel savings and emissions reduction aligns well with international efforts to combat climate change and create a more sustainable future. As we move forward, the positive knowledge gained from the implementation of SmartStart automatic engine start-stop systems can serve as a blueprint for the integration of other innovative technologies in the railway sector and beyond. By addressing the challenges head-on and continuously refining the technology based on real-world feedback, the industry can pave the way for a future where efficiency, sustainability, and progress move together. So at this point, I'm done my spiel, but I would love to hear what you guys have to say, and I'm hoping that you guys were able to forward some questions to Shabam. I'll turn my camera back on now so that you can see my face. Yep. Welcome Am and Shabam back as well.
Hello, everyone.
So all right, you guys are still awake.
It was a good presentation, and yeah, we do have some interesting questions out here, and I'll assign these to you. So Garrett asked this question on the payback period slide that you shared, slide number 17, I believe. This is based on, the question goes on, this is based on fuel savings alone, correct? Does not include the qualitative value of manual shutdown and engine life extension. The case study we discussed, so this is the question.
That is correct. So that is purely based on the calculations of fuel saved based on the number of hours that idling was reduced. So yeah, that's not even taking into account a study of mechanical components that maybe had extended time on them, just purely on fuel savings.
Yeah, it's a
Okay.
great question. Steve, I'll add to that. It doesn't also include the impact of, if the manual shutdown policy is in place, not getting to the engine in time and starting it, and maybe having failed engine starts, which can have operational cost impact as well.
Yep, the infamous dead won't start, which we didn't touch on a lot in there. Yeah, that does have a monetary value attached to it as well that we didn't touch on a lot. So thanks for bringing that up.
We have another question like, my locomotives have Gen Start. Does SmartStart work with these systems? Why don't you take up this question?
Gen Start. Okay, so I think Steve mentioned earlier that the system is designed to be fairly locomotive agnostic. So, if it's a switchyard locomotive, mainline locomotive, starter motors, Gen Start, traction alternator start. SmartStart's integration is pretty easy though. The actual starting circuit stays intact. What SmartStart is doing is sending a start digital signal to the contactor or the relay that initiates the starting sequence. So as an example, on a progress unit, maybe an STA contactor, and maybe on a G unit, maybe something like a GSS contactor, that sort of thing. So it's very locomotive agnostic, and pretty much if there's some kind of electric start involved, you can handle it.
Okay, thank you. We have another question. Steve, why don't you take this because you did the presentation? Does SmartStart reduce the useful life of electric and or air starter motors? Is there a type or brand of starter motors that SmartStart is known to work better with?
Yep, that's a good question. So that was something a little more relevant a lot of years ago. Obviously, these engines were designed, to start once or twice a day and run all day, and now we're putting demand on them to start and stop, 5 to 10 times a day. So that was something that we had to grow with over time. I don't have a particular brand of starter motor that I could recommend that works any better, because what we've really done is we've worked to optimize starting. So by implementing, peripheral devices to help with fuel delivery on cranking, like our governor assist pumps, and doing things like detecting starter abutments and releasing those. So when starter motors don't align properly, that can stop cranking from happening. So we've done a lot of optimizations on the software level, on the data analysis level to really reduce strain on starter motors over time. So I don't know if you have anything you'd like to add to that, Am, but
I think you covered it pretty well, Steve. Maybe, and apologies if you mentioned this, SmartStart also restarts the engine when the engine water temperature is warm, the battery state of charge is still in a pretty good place. So technically, the crank should be an easy crank, which should be easy on the starting motors as well.
Yeah, that's a good point.
So we have another question. And why don't you take this one? What kind of data does SmartStart provide?
Sure, good question. And I think Steve did a good job of covering some of this in a presentation. But I'll try to get into some details here. But So there's a few categories. So first of all, there's the performance in terms of like what the actual savings are. People buy SmartStart for fuel savings and emission reduction. So it quantifies the actual savings. It can be you can narrow into certain periods, or you can go over the life of the of the SmartStart on the locomotive. You can look at a fleet level as well. More importantly, it's not only what you're saving, it's what you're not saving. And so SmartStart, sometimes the engine going to continue to idle because maybe you got a leaky air system or your battery's aged and it takes a lot longer to charge than it should. So the report not only tells you what you're not saving, but why. You didn't, on this locomotive, you had that extended idle time because of air or because of battery charging or something like that. So it helps to point towards the reasons why you're not maybe realizing the savings you could and the actions you can take or areas of focus that your maintenance folks can take as well. There's also the duty cycle report. So SmartStart also reports out on the actual utilization of your locomotive. So like, idle DB time, notch 1 through notch 8, and those sort of things as well. There's also faults and alarms and historical alerts, like maybe the engine unexpectedly shut down because of a mechanical issue, or maybe it ran out of fuel and unexpectedly shut down. So there's a fault archive as well. And I should note that this data is accessible not only on a locomotive via laptop, but as Steve mentioned, the Sabre, the remote monitoring telematics solution that we offer with SmartStart as well, it's accessible remotely too. And I mentioned fleet level. If you're looking at things at a fleet level as well, it can be a lot of data. So if you have a large fleet and you've got a lot of SmartStarts installed, the railroads certainly are well equipped to do their own analysis, but we also offer a service to take a lot of that big data, narrow it down into areas of focus, and provide and synthesize those into maintenance actions for the railroad folks so that they can save time not having to do this, and also take some maintenance to maximize fuel savings.
Okay. So the next question is, what do you do in hot weather where turning the engine off shuts down the AC? So
Yep, no, that's a good question. So in that situation, the AESS would probably only be active more between shifts, after shifts, during breaks and things like that. Yeah, if you're in an extremely hot climate and you need to run AC, then that may be part of the plan that needs to be thought of when it comes to the strategy of which AESS works for your situation. So at this point, with the technology for AC on there being a significant drain on the batteries, it may not be the best choice to shut down if you need to run AC all the time. So, but that's something that could be addressed with some work with ZTR to talk about other ways where we could really utilize the idle reduction time that works with the operators.
and we have a very interesting question like this says, our clients have issues with Waptec AESS starting more than the 8 times per 24 hours threshold. They are in fact starting 15 to 30 times per day, making the product undesirable to the point where they are being manually shut off. So how does SmartStart function differently that allows it to reduce the daily startups and function with lower voltage batteries better than the other AESS in the market?
Yeah, so this is something where the agility that we have within ZTR, based on all the years, 30 years or more that we've been doing AESS, we can set up more concrete start limits per day. So the question's interesting. It says that there's supposed to be a high limit, but you're not seeing that enforced. So that may be. I'm wondering if there's a software configuration that is assumed to be on some of those units that maybe isn't and needs to be loaded, but that's the kind of stuff we could definitely look into. Also, another thing that we've done in recent is we've paired some other technology along with our AESS. So we've been working with some supercapacitor start assist systems in the last 5 or 6 years, and they significantly subsidize the power that the batteries used to have to supply by keeping a bank of supercapacitors charged and dedicated only to starting. So that, alongside in parallel with an AESS system like SmartStart, also greatly reduces the strain on the batteries and then makes it possible to shut down and start up more often without having that negative impact that you described in your question. So I don't know, Am, if you have anything to add to that, or?
No, again, I think you covered it quite well. Maybe the only thing I'll add is, yeah, so SmartStart has a default limit on the start stops per day, just because of the detriment too many of them can have on Locomotive potentially. We also have some algorithms in place to look at, like, certain events happening too close together. Like if we notice like repeated battery starts or air starts, the algorithms look at it and say, look, there's obviously something going on here, and we're going to be stopping very, very frequently, which isn't great. So we're just going to, put the system on hold for a short period of time here until the issue is resolved.
Yep, that's a good point. So we've talked kind of a bit crudely about some of the algorithms, but there's actually a lot of nuance that has been programmed in and adapted over time. So I think Am's discussing something we call extended idle. So if we're seeing, consistent, let's say low pressure restarts happening, so many within a certain period of time, we'll actually deem that as problematic and go into an automatic extended idle period. Notify the operators remotely through raising a notification about that extended idle situation, and then after a predefined amount of time, or sometimes the next calendar day, go back to the original scheme of shutting down and starting up. So I hope that answers the question that we had.
Yeah. And we have two interesting, very related questions. Maybe Steve, you can take them up. Like, what if the locomotive is auto shut down and I have to perform maintenance?
Yep. No, that's a good question. Obviously, safety's got to be key, first priority for everyone. So we get this a lot. So there's a few things I'd want to establish. So if a locomotive is shut down manually, it will not be restarted by the AESS. So it's kind of the golden rule, so to speak, which is the SmartStart will only start up a locomotive that was shut down by SmartStart. So any kind of manual intervention like EFCO, so emergency fuel cutoff switch press, low oil trip of the engine, basically anything that shuts the engine down that wasn't intentional by SmartStart will deem it disabled until the next time it's manually started. The second thing that we have is that there is a switch on the SmartStart that you can put into an off position. So it's just a tactile switch, physical switch, and that while it's in that position will also just lock itself out from being able to auto restart. So if you need to have the engine, the locomotive powered up electrically to do some diagnostics or some testing, but you don't want it to start automatically while you're performing those tests, then that's a safe way to perform that, by just turning the enable switch off. And there's indicator lights that will tell you the status of the SmartStart. So green means it's in an automated state where it could be doing anything, and then red tells you that it's disabled and it will not be performing any automated restarts.
Okay, yeah, I said there was a related question, so that it was that. How do I tell the difference between an auto shutdown and a manual shutdown engine?
Yeah, okay, that's a good question as well. So if you are on a unit and you want to know whether it's capable of restarting on its own, the first thing you'd want to look for is that auto start indicator light. So if it's green and the engine shut down, then that tells you it's enabled and in an auto shutdown state. Because if it were disabled and shut down, the light would be red. And then the second/third indication would be there's an audible chirping noise, so a periodic short blast of the siren that the SmartStart uses, and that would be happening roughly every 20 seconds for about half a second. It kind of sounds like a bird chirp, which is why we refer to it as chirping. So if you hear that bird chirping sound while the engine is not running and you see the light is green for the auto start health indicator, then you know you're in an automatic shutdown. Anytime the light is red, you know that shutdown is manual, and an auto restart will not initiate during that time.
Okay, and there's another question that says, is there added maintenance with an AESS or SmartStart equipped locomotive?
Sorry, could you repeat that? I didn't catch the very beginning.
Is there added maintenance with an AESS or SmartStart equipped locomotive? Like, is there any added maintenance that we need to do?
Yeah, I can take that one as well. So yeah, I think the short answer is yes, but it's less maintenance and more just doing a periodic qualification. So obviously starting and stopping of an engine, if it's not working properly, is going to create issues with operations, which you don't want to have. So all we recommend is when a locomotive is in for any type of maintenance, that a basic check of initiate an auto shutdown and restart, make sure that that's successful. Otherwise, the components, the sensors, the peripherals, they have very long maintenance intervals, some of them which we really only ask to be checked every 3 to 5 years or more, and replaced maybe every 10 years at the most. So, and those are all laid out in our maintenance manual and documentation.
We have another interesting question over here. Like, we are part of a mining operation and therefore we also own Komatsu 830E and 930E off-highway diesel electric mining trucks. So can AESS conceptually work on these trucks too? Does anyone currently use it in this application? That's a very interesting question, like AES application on diesel electric trucks.
You want me to take that one, Steve?
Yeah, if you want to start, I can help out as best I can.
Sure. So, Shabam, can you just repeat the beginning of the question? Mining trucks, and there were some numbers there.
There are two trucks. Like, we are part of a mining operation and therefore we also own Komatsu 830E and 930E off-highway diesel electric mining trucks. So can AESS conceptually work on these trucks too?
Yeah, great question. And I think we have been approached on this in the past. We didn't really expand out into that part of the industry, perhaps, if I recall. But if the question is conceptually, then yes, it is applicable. Okay. I mean, if it's an engine and it can start and it can stop, and there's parameters that we can access, then yes.
And there's another dimension added to this question. Like, they specify that they have Cummins engine with GE control cabinets, just like locomotives. So
yeah, it's sounding better and better all the time. But yeah, I mean, we need to probably know a few more details, but conceptually, yes. I mean, AESS, I mean, in the rail industry, I mean, I believe there's, there's call outs in the other industries as well, like the trucking industry. So, having this kind of application in trucks, whether they be mining trucks, it's not really a far reach.
Yeah, and we have done, even within the locomotive world, a lot of different voltage levels, because that's typically what we're looking at. A lot of times automotive will be more lower control voltage. Locomotives, obviously your unique 72 volt range, but we've also done 110 volt DC systems. So yeah, when it comes to the operating voltage, we have the ability to generate or create hardware that can adapt with and work with those different ranges. So yeah, and that's another thing we should say is for these type of specific questions, feel free to reach out to us afterwards through our website, ztr.com. You can email me, Steve Cable, so at scable@ztr.com, and we can work closely with you to make some of these specific applications, or at least do a feasibility study on them.
Yeah, we are just on time and we have few more questions here, but I don't think we would be able to take them. However, we would be replying to the askers, and yeah, I'll pass on all the details that Steve just said, and thank you all for joining. We appreciate the engagement and the insightful questions. So you can look out for a post-webinar survey and the white paper in your inbox soon. If you have missed asking questions or any other question pops up in your mind, you can post that to us in the survey that will be sent to you. And the webinar recording and deck will follow within the next week. So thanks again, everyone, for being a part of this session. We enjoyed it. Hope you too. Thank you.
Thanks, everybody. Appreciate it.
Thank you.